Hi, my name is Andre, and in this short video, I'm testing how AI can control Blender through MCP. For this experiment, I'm using OpenCode connected to Blender via the native Blender MCP add-on. The main idea is to give the AI direct control over the scene creation process. In this case, GPT 5.5 is running in X-high reasoning mode. I gave it a reference image and asked it to recreate the scene in Blender. But to make the test more interesting, I didn't ask only for modeling. I also asked the AI to think through the animation and build it into the scene. So the goal is not just to generate a static 3D setup, but to see whether the AI can understand the visual reference, create the environment, add the main elements, and animate the result. I'll speed up some parts of the recording because the process takes time, but you'll still see the main steps and the final result. Let's see what it can do. The model finished the task in 11 minutes and 7 seconds, and as we can see, the result is quite solid. It's not a perfect match to the reference image, but the model clearly understood the overall look and structure of the scene and tried to recreate it as closely as possible. We can also see that it generated all the key elements from the reference: the floating island, the palm trees, and the flowers. On top of that, it set up the lighting, added a camera, and even created a backdrop so the render would have a background similar to the one in the original reference. And most importantly, this is not just a static scene, it's also animated, exactly as we asked. The animation itself turned out pretty good as well, especially considering that the whole setup was created by AI. Let's also quickly check how this looks in the final render, with the lighting and materials. Of course, there are still many things that could be improved or refined, and we'll ask the model to work on those later. We can also see that the model gave proper names to all the created objects and even organized them into logical groups. This is a small detail, but it makes the scene much easier to understand, inspect, and continue working with later. We can also spot a few issues here. Some objects are floating slightly above the ground instead of sitting properly in place. That's something we can try to fix in the next step by asking the model to refine the scene and correct those placement errors. The model finished the update and said it fixed the issue, but as we can see, it didn't correct exactly the rocks I meant. That was likely my mistake, since I should have specified the exact object names in the prompt. For now, we won't spend more time on this and we'll move on to improving the scene lighting. I also asked the model to replace the backdrop with a SkySphere. As we can see, it completed those changes successfully. The backdrop was replaced, extra lights were added, and the overall lighting setup was adjusted quite differently from before. Let's take a look at the current result. In my opinion, it already looks pretty good, maybe just a little too bright. At this point, we could easily stop the test here because the result is already acceptable. But just for the sake of testing, let's push it a bit further and ask the model to refine the scene once more. This part of the test was successful, but the scene became too dark. So I asked the model to compare the current render with the original reference image and try to match the lighting more closely to the reference. Here I'll use a little less speed up so it's easier to follow the process in a more interactive way. You'll be able to see how the model adjusts the lighting step by step, comparing each new render to the reference image and fine-tuning the light intensity along the way. So overall, it's not a perfect match to the reference, and there's still room to improve. But the fact that the model was able to build the scene, set up the animation, and get this close already feels very impressive. Of course, if the goal was simply to create a 3D model from this image, I would use a different approach, for example, Trellis 2, which is designed specifically for image-to-3D generation. But this test was about something else, seeing how an AI model can control Blender directly and use its tools to build and animate a scene.